In our modern lifestyle, people spend between 80 to 90% of their time daily inside buildings such as homes, offices, schools, doing many activities. To analyze such comparative study and achieve its aims by studying indoor environmental quality parameters and indoor air quality and its relation with ventilation, human health and thermal comfort, which reflecting directly on human performance and productivity. To find best ventilation strategies and criteria by studying 3 international examples and analyzing 2 case studies to reach a clear guideline for improving indoor environmental quality and implementing the most effective ventilation criteria. The importance of studying the impacts of ventilation as a significant factor affects directly on indoor environmental parameters to achieve a healthy level of indoor air quality and sufficient levels of thermal comfort, especially in housing sector to protect human health and enhance their indoor performance and productivity. Ventilation is an important modifier of indoor environmental quality and has a relationship with overheating, indoor air quality, and human health and thermal comfort. Ventilation allows to exchange between inside and outside of homes. This allows to control air quality and contaminants from internal sources. In addition, control temperatures and humidity to reduce the health risks and reach well-being threshold. According to ASHRIA 55 standards, the ideal thermal comfort zone in homes falls within 30 to 70% relative humidity and temperatures between 20 to 24 degrees, depending on air velocity. If conditions fall out of the comfort zone and air is still without any exchange, our bodies respond to it. It is possible when the air calm, the temperature cool, but the humidity is high. We will still feel warm because high humidity slows down the evaporization of our sweat. Our bodies generate heat every second. If the heat cannot release to cool air, we feel hot. Heat is taken away by airflow around our bodies, turning the sweat from liquid to vapor. If the surrounding humidity is lower or the temperature is lower or the surrounding air movement is quicker or any combination of them, the cooling effect will be faster. To measure the range of indoor thermal comfort, researchers developed a PMV scale, predicted mean VOT, by using 2 essential parameters, air velocity and air temperature, both parameters directly related to the ventilation system. In hot to humid countries, the summer is harsh season. We block doors and windows because of hotness and high humidity. Actually, we also block air exchange, which means we breathe only the trapped air in the indoor spaces. As we breathing oxygen and breathing out the CO2, the percentage of oxygen will be lower. You may feel sleepy or lazy because the high percentage of carbon dioxide. At the same time, your furniture and home's building materials are releasing contaminants. Indoor air pollution is considered one of the highest 5 health hazards reported by US EPA, US Environmental Protection Agency. The poor indoor air quality has notable negative impacts on human health. It appears through many symptoms such as headaches, irritation of the nose, eyes, and throat, lethargy, nausea, asthma, and dry skin. The awful ventilation system inside the occupied buildings can easily cause SBS, sick building syndrome, and several illnesses such as metabolic diseases, respiratory problems, and poor human performance, and make the occupants less productive due to the prolonged exposure to poor indoor air quality. The ventilation system directly affects the fresh air supply and indoor air quality. Therefore, ventilation quality directly affects human health and thermal comfort. As a result, a good ventilated indoor space in a healthy building can make people more energetic, productive, and have good mental and psychological well-being, reflecting on their health, external and internal comfort. There are many types of cooling and ventilation systems, offering various levels of daily humidification, filtering, cooling, recovery, and choice fresh air source. The primary function is to supply sufficient fresh air to maintain indoor air quality. Moving on to the first example. The surrounding site works like a small oasis by ecosystem, provided water, plants, and buffer zones. The house is designed with large windows to create a cross-ventilation system through all rooms. The applied strategies to improve cross-ventilation mechanism: 3 courtyards, long and tight terrace, large windows, pergolas, and pools. The courtyard in 3 different directions work as passive cooling strategy to reduce humidity and create differences between indoor and outdoor temperatures. The shaded long terrace in the upper floor work as a buffer zone to increase airflow and air circulation. When the air velocity go up, will affect on indoor temperature and maintain PMV value and improve indoor air quality as a result of decreasing the contaminants and high rate of air exchange. Also, large size of windows will allow more air volume to pass into indoor spaces and achieve cross-ventilation requirements. Finally, pools work as an evaporative cooling surfaces, which decrease the surround temperature before go inside the home. Moving on to the second example. To ensure indoor environmental quality and family members' well-being, the sustainable solutions and analyzing of building physics applied to the house using passive design to optimize indoor environment and reduce energy consumption. The air movement designed to be continued inside the building in a vertical way via atriums and in a horizontal way by ventilation brick blocks and openings, using the buffer spaces to increase the relative humidity to maintain the indoor environment within comfortable levels naturally reduces the need for AC and fans. The house design has greenery areas in both the front yard and backyard to control air quality by using the yards as multi-layered filters, green filter system to decrease harmful smoke and dust from the house's surroundings. To protect the indoor spaces from air pollutants, green filters are also applied inside the kitchens and toilets. After applying the strategies, indoor air quality is considered safe and clean for occupants' health. Moving on to the third example. Passive Lab House used simple passive strategies to arrange the spaces and reduce the indoor temperature by 4 Celsius degrees and maintain the indoor air velocity and humidity. The project has many overlapped void spaces to ensure accurate work of natural ventilation. Slight indoor ramps are designed to be vertical circulation and work as wind chimney by putting a reflective pool under it and a tripled volume with an upper skylight with airflow openings. The effects of the pool will be high air pressure, low temperature, and high humidity. In contrast, the effect of skylight and openings will be low air pressure, high temperature, and low humidity. Indoor airflow will work passively by releasing the hot air by water and flowing in a vertical way to the upper openings in continuous movement. This will keep the indoor air fresh and clean with good quality and suitable occupants' health. The first case study research selected double-story house in a hot humid climate in Thailand to study the effectiveness of stack ventilation on indoor environmental quality in a hot humid climate by adding opening in entry door and extra openings at the rooftop to create high differences between outdoor and indoor air temperatures and relative humidity by generating buoyancy for a stack ventilation system. To measure the air temperatures, wind speed, and humidity by using scientific instruments inside both houses to calculate the accurate data and study the differences between cases. As a result, the house with a stack ventilation approach has a lower indoor air temperature of about 0.7 Celsius and lower humidity of about 12% less than the base case house. Stack ventilation can reach 1.06 air changing per hour if only 0.1% of area of building openings have stack ventilation. Moving to the second case study, Medina Jumeirah village in Dubai have courtyard summer houses called Dar al-Masyaf. Medina Jumeirah forms a virtual island looking down upon wind towers, courtyard houses and pools. The combination of green design techniques used in the project will not only reduce energy consumption and environmental impact, but also reduce running costs, create more pleasant indoor spaces, improve occupants' health, and reduce pollution. Design strategies that minimize the need for mechanical cooling systems were adopted, including proper shading, natural ventilation, thermal mass, careful setting, and orientation decisions, and good landscaping. Natural ventilation applied by wind tower and courtyards. Natural ventilation which used the passive stack effect and pressure differential to bring fresh cooling air through buildings with limited or no mechanical systems. This strategy has been adapted by incorporating different means of outdoor air intake, including operable windows. The wind tower has been used in Medina Jumeirah to increase the airflow in buildings. Other features include fresh air inlets located near floor level, use of atriums and courtyards that have been adapted to enhance the stack effect and to speed the indoor airflow.